So now we're going to take this linear programming idea and we're going to actually find the maximum and minimum. So we're going to start small. We're going to be given the maximums and the minimums. Okay, so I'm just going to show you how this relates to what we just talked about. So we talked about some of our vocabulary. There's our graph down there. They've already given us our objective function. They've already told us this is the objective function. They've already given us our constraints or our inequalities that we're going to graph. And so what we're going to do is we're going to just basically graph those inequalities, find the feasible region. And I'm going to show you a little trick that I like to use because you don't want to shade you don't want to shade 4 times. It's going to be confusing. It's going to be hard to see. So I'm going to teach you a little shortcut on how you can wait till the end to actually shade the feasible region. Okay? So let's go through the steps first, and then we'll kind of fill this in as we go. So the first step is to make sure that all of the constraints are either in slope-intercept form or are horizontal or vertical lines. So we need to make sure that we convert to slope-intercept form if possible. Okay, and then from there, we're going to graph each function or each inequality and decide where the shading would be. But again, I mentioned we're not going to shade it until we get kind of towards the end of our graphing, okay? So let's do that first, and then we'll come back to our steps. So I'm going to call this number 1, number 2, number 3, number 4. The first 2 are really, really easy for us to graph because these are horizontal and vertical lines. One is a hoi and one is a vux. You should see that this one has an X in it. X is in the word vux, and vux stands for a vertical line that passes through 0. Well, the vertical line that passes through 0 is the actual x-axis. So the x-axis is one of our constraints. Now look what it tells us about that. We only want the values, the x values, that are greater than 0. Well, if you're focusing on my x-axis for just a moment, or I'm sorry, this is my vertical line. If we're talking about that, but we see that it crosses right here, we know that the values that are greater than that value on the x-axis is to the right. So automatically, no matter where we draw in all of our other inequalities, this region here and this region here are not going to be the feasible region. Okay, the feasible region will not be located there because this inequality alone limits it. It says not here and not here. Okay? So then my second inequality, that one is y is greater than or equal to 0. That's a hoi. That's a horizontal line passing through 0 on the y-axis. So that line is going to go here. And so now we have 2 new regions. We have this region here and this region here. We know it can't be these. So we're going to base it upon this line right here that we just drew in. Okay, and look what it says. It says greater than that line. Well, greater than would not be below. Greater than would be above. So I can limit to this region up here. So just with 2 inequalities, I've already narrowed down a little bit about where the feasible region is going to be. Okay, and all I'm doing is putting little X's on the regions it can't be. Okay. So let's look at number 3. Number 3 is not in slope-intercept form, so let's change that first. Let's subtract the x. Y is less than or equal to negative x plus 5. Let's go ahead and graph that. That's 5 on the y-axis, so 1, 2, 3, 4, 5 for the y-intercept. The slope is negative 1 over 1, so they're just going to be in all of the corners going downwards. And all of the corners going upwards. And again, I can sketch in that line. All right, and then let's look at that line. That line says all the y values that are less than that line. Well, that means my only two possibilities are either here, here, or here. But less than would be below the line. So that's going to limit it to this region right here. Okay, so now I know those are taken out of the possibilities of the feasible region where we're going to shade. Okay, and then the last one is going to define it just a little bit further. So I'm going to do the same thing I did before. 2y is less than or equal to negative x plus 8. Divide by 2. We get y is less than or equal to negative 1/2 x plus 4. So plus 4 is right there, just slightly below the other y-intercept. And then the slope is negative 1/2. So down 1 to the right 2, 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 down 1 to the right 2. And I could even continue it, up 1 to the left 2, up 1 to the left 2, up 1 to the left, up 1 to the left, up 1 to the left. It's not going to matter, but we can still put it in. And then I'm going to go ahead and draw in my line. Now, what you should see is that that region, or that inequality has created 3 more regions, and we don't know which one it is until we actually use that line. It's either this one, or this little tiny sliver. So look what it says, less than that line. So since it's less than that line, that means that where that line is, it's going to be everything below it, okay? And so that's going to be, and remember this region right here is not included because that was part of the greater than of this line and it was supposed to be a less than. So this one's going to have to be less than that line, which means that our feasible region is going to be right here. Okay, hold on, I kind of shaded in. This little sliver right here is not included. There we go. All right, and the reason why this little sliver right here is not included is because this is the line that I just drew, and the values that are less than is going to be below, not above. Okay, so that little teeny tiny sliver right there is not part of the solution. So you can see I kind of marked out this whole region over here, right? I marked out this whole region, which also includes that because that's on below the y-axis or the x-axis. And that left me with this. And then just the other 2 lines that I drew in and what their symbols were determined that it was this as the feasible region, okay? So now that I have my feasible region kind of in there, my next goal is to identify the ordered pairs of all the vertices. So this is a vertice, this is a vertice, this, and this. And so I have to identify those ordered pairs. So I'll just go ahead and write those over here. This one is 0, 1, 2, 3, 4. So 0, 4. This one obviously is 0, 0. This one right here is 2, 3. And this one here is 5, 0. Okay, and then we will finish up the next steps, the last 2 steps in the next video, so the video doesn't get too long for you to download.